Good morning, everyone. Wherever you are, thank you for joining this webinar. It's about evading Mother Nature, navigating UAM weather conditions. We have Don here, our CEO from True Weather, here to present some of the material and some of the really great innovation happening at True Weather and some of the partnerships happening at Skyway. So with that, we'll just kind of get into it, and I hope everyone enjoys the webinar. So to kind of give it a little bit about what Skyway is, Skyway is a PSU by nature under the ConOps, FAA ConOps. What we do is we provide data services for UTMs and eVTOLs. We also have an ATM solution for vertiports, so we're definitely innovating in some of the route management aspects and route risk management, as well as the UAM environment and ecosystem for sending data, secure data to ATC agencies such as the NAS and the FAA. So here we're actually doing a lot of innovation in vertiport development, as you can see from the image behind me, as well as some of the standards, global standards of and data security of UAM in eVTOL operations. With that, we have also True Weather. Again, one of our partners, Don here. True Weather provides some of the leading data innovation around UAM, and we'll get into more about what that means and how that's significant for UAM operations. But they are definitely one of they are the leader in weather, a weather platform for the future of cross-shared data platforms for eVTOL aircraft and drone operations. So as we go through the webinar, if you have any questions, please put them in the chat below. We'll definitely be having a Q&A session after the webinar, and we'll be able to address those questions as we go forward. But please, if you do have them off the top of your head, just go ahead and pop them in, and we'll address those at the end. So for today, you have here myself. I'm Clifford. I'm the CEO and one of the founders of Skyway. I have over 10 years experience in the cybersecurity industry. I've built cloud architectures in the past, large data center architectures. I've also done a lot of radio communication systems for aircraft and IoT sensors in that industry, and I'm mostly notable for doing a lot of encryption methods back in the day, doing government contracts and things of that. Don, do you want to go over your background?
Hi, Cliff. Well, thank you for putting this webinar on today. I'm Don Berchoff. I'm the CEO of True Weather Solutions. Let's just say I'm old. I have about 40 years experience in the weather, aviation, logistics industry. I'm an aviation meteorologist by trade, but through the years, I built my chops up around technology. I'm an operator. I was fortunate enough to run an Air Force base in Central Asia, the main staging base in Afghanistan, Manas Air Base. And so there's no better way to test your mettle in weather and mission integration is trying to get aircraft off the ground when you have 12 inches of snow in 5 hours, which, by the way, we did get those aircraft off the ground. I'm also consider myself pretty expert at complex systems. And as an entrepreneur that started True Weather, that's been a key component of our very innovative platform that we've built to plug and play different data sets. I served 24 years in the Air Force. I was the National Weather Service Science and Technology Director for 4 years. I was able to accelerate and on-ramp science and technology in the labs and universities into weather service operations. And I also chair the ASTM F38 Weather Supplemental Data Service Provider Standards Group, which is really critical because we need to change some of the standards around aviation weather that's been built for manned aviation to better accommodate what we're going to be doing in UAS and eVTOLs.
Great. Thank you, Don. So you got really two masterminds here in this webinar, which is good, which is
in
awesome.
Our mind anyway, right?
Yes, right. So a little bit of the overview of what we're going to be going over today. We're going to go over at a high level the UAM industry and the airspace that we're talking about, and we're actually flying in. Some of what the weather looks like today and what it will look like tomorrow. the challenges for UAM aircraft at low altitude, and how a microweather overview on how to optimize the new weather environment and the data streams for that. Information data synchronization, and but not least, weather data and how that affects navigation and how we integrate all that information into one cohesive environment so everyone can traverse the airspace of the future nice and safely. To kind of get a little bit into where we're talking about, UAM and AAM airspace is a lot different from traditional commercial airspace. So when we think about that, conversations in the CONOP and FAA and NASA is really looking at 5,000 feet and below when it comes to UAM and AAM. And where we look at remote ID laws regarding the FAA, it's looking like drone operations will most likely be happening well under 400 feet, and eVTOL operations 400 feet AGL and above up to about 5,000. We don't really see these vehicles traversing any more than 10,000 at that point due to the integrity of the vehicle and the weather and certain aspects of the actual aviation structure. So we're most likely drone operations till this time, as we hear it, will be below 5,000 feet, which is a critical thing to understand here when we talk about weather and navigation here at Skyway. So with that, I'll give it to Don to explain some of the gaps here in the industry. Don?
Well, Cliff, you guys ran an amazing video in the beginning of this. And I think, the point I want to make is most of that hazardous weather that developed, as you saw in that video, a lot of it occurred in the boundary layer and the moisture influxes and how that moisture is moving to build those thunderstorms up. And believe it or not, that boundary layer, which is about anywhere from 3,000 to 5,000 feet in the atmosphere, up to 3,000 to 5,000 feet to the surface of the Earth, it's our turbulent layer. It's where all the action happens. And that is our least measured area in the atmosphere. So we are running a lot of models. We do a lot of model development, but basically a lot of that model development is not based on having a lot of real-time data below 5,000 feet. We have satellites that are very good at penetrating the atmosphere down to 5,000, 3,000 feet, but the signal attenuates because the atmosphere gets so dense. And so we kind of lose some of that as we get closer to the surface of the Earth. Really, the weather radar is a great tool, but it's not everywhere. It's not ubiquitous. And it also suffers from what we call curvature of the Earth. So the beam goes straight out, but as soon as you get out, 50 miles from that radar, 100 miles, that beam is sitting much higher above the ground level. You can actually have precipitation on your radar and it's not hitting the ground. Or you can have precipitation at your site and it's not on the radar. And that's what a lot of people don't understand. Everybody wants to be an expert in interpreting weather radar. That would be like me being an expert in interpreting my MRI if I had a brain tumor. I prefer to give that to a doctor, right? Because there's a lot of things that people don't understand about remote sensing that are impacting those feeds. But more importantly, we only have 2 balloon launches a day that collect real data up through the atmosphere. Here in the United States, it's about 122 sites. That's very coarse. And we also get data from aircraft landing in and out of airports when they come through that boundary layer, but those again are very scattered. So we have a gap that we have to close in order to really understand the micro weather and the microclimates that are really going to impact drones and air taxis. And that's what part of what we're working on is trying to fill that gap from the bottom up rather than from the top down. So basically, when we talk about advanced air mobility aircraft and flying below 5,000 feet, that's where a lot of the weather occurs also. Most manned aviation get above the weather, right? Except your general aviation and your helicopters. And I'm sure if you talk to a general aviator or a helicopter pilot, they'll tell you that their areas are underserved by weather infrastructure. There is no doubt that the reason that they're successful and able to fly today is because they're on the aircraft. And they're a human sensor themselves, and they get out of the way of a bad weather forecast or for us not having accurate information about what's happening at a specific location. So this idea of flying blind is what we're going to see with the drone industry. And bottom line is when you're flying blind, you're increasing your uncertainty about what's happening. When you increase your uncertainty about weather conditions, it means when you combine that with the sensitivities of these aircraft that are not as capable of withstanding weather and wind conditions that a large unmanned aviation are, that means you got to have more conservative business decisions because you can't afford to have accidents, right? So the lack of low altitude weather is going to be a limiting factor. I think most folks think I'm going to use my app, I'm going to use this or that. Those are not built for this. In fact, aviation weather in itself requires a special training by our meteorologists because most general weather information is not built for aviation weather. Ceiling height, cloud height, icing, turbulence, microbursts. Show me where those are on a weather app generally. You won't find them. So that's because it's hard. If it was easy, they would be on the weather app. We focus on that. We focus on the low altitude weather. We're looking at this data desert below 3,000 feet and also urban areas where you have Ventura winds that can really cause problems and turbulence that are not measurable today. You can't use the ASOS at the airport to know what the winds are doing in Manhattan. It's almost better not to look at the METAR if you're in Manhattan, because all you're doing is giving yourself a false sense of security about what's really happening. And the other thing is we're advancing our AI and ML, but new data sets are required for training that AI and ML. And most of those data sets they're using to train today are model-based. It's models training models. And there's already errors inherent in that. And I always tell people, if somebody's selling you an AI or an ML weather tool, ask them how much real data actually was used to train that data set. And I'll give you an idea. So what we're really looking at is, we're facing challenges with UAM, but they're not insolvable. The question is, are we willing to do what it takes to mitigate and address these issues in a way that's going to be proactive rather than reactive? And I think for a drone, the main thing is we're going to lose the human sensor. That's the best sensor we've ever had on an aircraft. When you lose that human sensor, if they're flying from somewhere in a bunker, if you talk to the Air Force who have been flying Predator and Reapers now for 20 years, what's their biggest challenge? It's icing in cloud. They cannot fly in icing. What's their second biggest challenge? They don't really know if it's there. Why? Because our forecasts for icing are not really very good. And there's a reason why they're not very good. They're not very good because we don't have a lot of data about it. We haven't been able to improve our science because the only way we can detect icing today is by flying in it. There's no instruments that can see icing. And so we're working on those kind of problems because when you start flying a drone, especially a heavier lift drone from 1,000 to 3,000 feet, guess where they're going to be flying a lot? They're going to be flying in clouds. And if you're in the northern climate, you're going to be flying in clouds that could have icing. And if our forecasts are over forecasting icing, you're going to be grounding your aircraft when you could maybe have flown. 40% of manned aviation today that is canceled or delayed due to weather, they could have flown. It's the uncertainty that causes them to be conservative. That's not going to work well for this industry, which is going to have tight margins, high velocity throughput. And so we need to get ahead of the weather problem. And that's what I said, get ahead of it. It doesn't mean it's not solvable. We just got to get ahead of it. And so things we're looking at are like winds above ground level. You can have 2 or 3 times stronger winds at 250 feet than at the ground. That means less battery power for you to complete your missions. We got to consider fixed wing aircraft and how updrafts and downdrafts are going to potentially cause those to rise up or down outside their area, their volume reservation. Icing, we talked about, freezing drizzle, freezing fog, very hard to detect. 1 degree change in temperature, you're flying 10 miles, you have drizzle, you might run through an area of freezing drizzle and freezing fog, and you may not know it until your aircraft starts to show that it's struggling, right? How are you going to know it's out there? And these low ceilings and visibility, which can be very microclimate, the only place we measure ceiling heights today are at airports. That's the only place. So imagine most drones are not going to fly at airports. They're going to be flying ubiquitously through mountain valleys and places where ceiling and visibility are going to be IFR when you think they're VFR. Now, that may be okay once we allow for IFR drone flight, but it's not okay today because the FAA says you got to be 500 feet below a cloud deck and have 3 miles visibility. How are you going to know you're within that authorization? The other thing is, think about what impacts by airframe and payload. Go ahead, Cliff.
Yeah, I think it's really critical here to understand that, nobody's going to want to go through a turbulent flight, right? Everybody's so used to that smooth, thin air at high altitudes. But when we're talking about VTOL operations at low altitude, this is where the turbulence is, right? And I know, the barf bag, right, so to say, on that airplane is going to be there, but they're going to need a lot of those in VTOL aircraft if we don't take this seriously and making sure that it's a smooth ride from point A to point B. And those operations that you mentioned, I think, are going to be critical when it comes to making sure a business can make a return on their operations, especially the amount of investment that's being put into this. So I do think that's a really good point.
The things in the eVTOLs that we have to pay attention to are the urban winds and urban canyons. You can't assume. Helicopter pilots will tell you when they try to land in cities, it's not always the most pleasant experience when the winds are blowing. And the winds aren't always blowing the way you think they're blowing because the buildings have a big say in that. And we also got to worry about pop-up thunderstorms on your business model. Because if you're flying eVTOLs and you have to get from, say, I don't know, Miami downtown to Miami International, and you get pop-up thunderstorms, yeah, you might be able to work around them, but how is that impacting your velocity? How is it impacting your schedule reliability and predictability? And how's that impacting your client who needs to get to an airport by a certain time? So these are the things that what I think about, because it's my job to figure out how to mitigate all this to help you get those rides up on time. That's what I did in the military. Bombs on target, cargo to the right location. So that's what we work tirelessly at. So the solution for tomorrow is really understanding that there's a lot of uncertainty today that causes unnecessary grounding. I believe that 30 to 40% of that is mitigatable. Even today, it's mitigatable. I proved that in the Air Force when we did a test with the Tanker Airlift Control Center at Scott Air Force Base. They were flying 100,000 missions a year of tankers and cargo missions and people, and they were getting 5,000 weather delays a year, every year. And what I learned pretty quickly is that they were not making usually the weather data to their advantage to make better decisions. They had their biases, they carried their, the baggage, their weather baggage. There are ways that you can maximize a risk management approach to weather and decision making that we could get back a lot more of those groundings. And we did it in the TACC in 1 year. We reframed how we introduced weather and how the decision makers made decisions. We cut it to 1,800 in 1 year. And we saved the Air Force $200 million, which was validated by Air Force analysts. And we were nominated for the Chief of Staff Team Excellence Award. So this is real low-hanging fruit that if you have good integration of weather and decisions, and those algorithms are taking advantage of the weather that we're confident about, you can make good decisions. So that uncertainty is what causes people to make decisions not to fly. It's the uncertainty. And part of that uncertainty is from the data overload and these data gaps. And what we do here at True Weather is we looking for that right data at the right time to make a localized decision. And then we bring that data together in our APIs. And we actually introduce that in a way for go, no-go decisions. We try to take all the complication out and take care of that for you and get you the pieces and the data you need to make a better decision. We also are flooding the zone now with novel plug-and-play weather sensors. We have 6 weather providers, sensor providers that are all top-notch. We're flying a Meteor drone in North Dakota starting in October to collect data up to 16,900 feet, pending an FAA waiver. And we're going to actually fly that drone into Icing at high altitudes to help improve our the flight of the Reaper drones out of that area. Right now, they're experiencing about a 30% delay or cancellation rate for their missions due to icing. And we're going to fly drones to see if the icing is really up there. If it's not, we're going to rework the forecast, and then we're going to get them flying. We think we'll get 30% more flight time. And the key here is that it's the ROI you've got to focus on, not the cost. If you worry about the cost of these sensors, you're missing the point. It's sort of like using free data and thinking you're getting something for free. That's good. Nothing in life that's free really is that good. It's going to be the same here. And there's a lot of science and technology on the shelf that's not getting out through the government today, out to the end user, that we're going to unleash and accelerate to help get that ROI. We're going to show it in a funded test bed at Hampton. We have 2 NASA SBIRs right now to set up an urban weather sensing test bed. We're going to have 2 rotating wind LIDARs, scanning LIDARs that go up to 6,000 feet, 10-meter resolution, 20-kilometer area coverage that's going to give us an MRI of the winds. And once we have that, we're going to learn things about real-time weather that are going to be so valuable to reducing that uncertainty.
Yeah, and I think to add to that, obviously we're partnered with True Weather, and we're doing a lot of really great stuff and a lot of the test beds across the U.S. I think one of the things that it's notable to mention here is that at Skyway we do a lot of research around data integration, and we are a data company. And what we realized is that weather systems are very, very old, right? They're antiquated. They've been around for a really long time. They're specifically designed for a certain type of industry. And so the one thing that we didn't want to do, reinventing the wheel, was how do you take that legacy type of information, convert it into a new age type of language, data language, that makes sense for everyone. And I think that was one of the huge values at True Weather, providing data services such as that to Skyway here, for our traffic purposes, and making sure that we can understand that data. But Don, if you could explain some of the really cool innovations of the future that are happening there. That looks like a really cool drone, a weather drone. It almost looks like a UFO in a way. I would assume you're going to get a lot of reports on that one.
Well, we're pushing the limit on the sensors now. This is not tomorrow technology. This is today. This is operating today. This is a commercialized capability. And we're going to be integrating these novel sensors into our ecosystem, working with, state, local government, federal officials, private sector. And this is just one of the tools that we're going to use to close those weather gaps and improve predictability and reliability in drone and air taxi operations. That's going to get you an ROI of 5-to-1 or 10-to-1. Guaranteed. It's low hanging fruit. It's going to take a blend of sensors, like I said, to fill these gaps. If somebody says, I'll just get you a surface weather station, that's not going to serve you well. We have a pretty good idea what's happening at the surface. The problem is we don't know what's going on at 250 feet. We don't know what's going on in the clouds. We don't know what turbulence is up there. These are the invisible threats that are going to really come to bite us, because manned aviation has been able to deal with those by flying through those areas and getting through them. But in the future, these are going to be impactful. And then we need to look at how you place your sensors. Every scenario is different. Every case study is different. There's no grid to put out, and there's no rule about how far an ASOS station is valid for the weather, because it changes every day based on the weather conditions. It also changes based on the terrain and the geography of the area. So you have to know what you're doing when you're thinking about how to array a sensor array, and especially in an urban canyon, where we have a tool now that we optimize the placement of the sensors around a vertiport to get a 3D picture of what's going on in a way that is at the lowest cost. And we're using low-cost sensors now and testing those with NASA. So it's going to take an IoT sensing strategy to really collect data from drones and from all these small sensors, but to make sure it's in compliance with the FAA. And that's where we come in. We're influencing and leading the ASTM F-38 with a bunch of really smart people. We got about 70 people on our group. We're working with the FAA, and we're trying to figure out how we change the standards and the rules to be more adaptive to this environment. Otherwise, if we don't close these data gaps, the economy for this business is going to be very difficult, right? We want to capture those rapid changes like you had in your video. Weather's dynamic. Just because you can't see it doesn't mean it's not happening. I always tell people a thunderstorm starts forming way before you see a cloud. And, if we could see that happening before the cloud forms, then we might know where it's going to, blow up and get some predictive lead time on that. And it's really about the micro weather detection and hazard detection and avoidance, because you can have data, but if you can't make it into a usable action. And so, we're going to be looking at geofencing. We have an alerting system that we're going to be rolling out in the next month. Cliff, your team is going to have the ability to put geofence weather hazards with other hazards that you're going to be concerned about in the airspace and blend those together into a one-stop shop. And that's really what True Weather is. We're sensors to solutions. We don't just say, here's a piece of the action. We're the Uber weather integrator and the expert around all of this. And having these data standards is going to be really important, because you need a means of compliance, because you can't have anybody put out crappy weather data to be used by aviators. Today, the aviators can't use any weather provider, manned aviators. It has to be approved by the FAA. And that's going to be the case in the future when we start talking about BV loss. We need reliability. We need cybersecurity. We need to make sure the system is going to work for you and be reliable. So the bottom line is that, you know, I'm a military guy and I went to National War College, and Sun Tzu was one of my favorite, you know, military strategists from 800 BC, Chinese. Not only because he mentioned weather in his book, but he did say, know the ground, know the weather, your victory will then be totaled. I kind of put my little profits will be totaled in there. And my favorite, you know, quote is, like politics, all weather's local. And if you don't understand it, you're going to lose the election and you're going to lose your ability to make as much money as you can make. So anyway, Cliff, that's kind of what we're focusing on.
Yeah, and I think the profit part, it hits home to a lot of UAM companies right now, right? Is how can we make the most profit without having to ground ourselves if it's not really necessary, right? I mean, that's just the key of it. If we follow traditional aviation in this new model, it's not going to be good for anybody, and it's a wasted opportunity. So I completely agree on that front. So to get a little bit about how Skyway is using true weather data and what we do here at Skyway with it, and what are the future aspects of it, you know, taking this data is really critical for us to understand the urban environment and how to route information, right? So, you know, it's really about de-risking those flight plans, rather they're planning ahead or they're en route where they need to reroute due to a pop-up weather that we just, you know, couldn't see prior to the route, right? You know, we don't want, as I mentioned, if we think of a future where there's just hundreds of drones in the sky, if one of them falls, you know, 100 feet very rapidly, and this is very well known in the aviation industry, that happens where there's a huge buffer. But if that were to happen, it would be a cascade effect. You're talking about a catastrophic failure out of the sky, and no one wants to see drones raining out of the sky, right? So, you know, it's very important that we understand those metrics and respond to them really quickly. And at Skyway, we're actually doing a lot of really good work on doing flight awareness and making sure that that the aircraft can respond to these threats rapidly. One of the things we also do with vertiport is making sure that the vertiport is clear and safe of weather. So we're putting sensors on those ports, you know, working with True Weather on making sure that we have the coolest and state-of-the-art systems for these ports, bringing those types of systems to the future, and really taking design into account when designing those type of infrastructure projects. Also, high resolution. I want to talk a little bit about what it means in urban environments. Obviously, you know, we don't take into account for a lot of stuff other than the everyday weather. But when it comes to UAM operations, drones doing business in here, buildings taking effect, right? Infrastructure, towers, anything that's in the way of this type of stuff inhibits traffic flow. And here at Skyway, we take it very seriously and want to make sure that traffic flow is safe, but also efficient across urban environments that make sense. So understanding the urban environment, making sure that we're deploying a proper network of sensors, and the standards for creating those rules around if your aircraft can go into those environments. So here at Skyway, we're innovating around how to aircrafts are categorized, right? So maybe a heavier drone can go through a certain amount of wind than a lighter one, right? We don't want to cut out the airspace for everybody, but if your vehicle can make it through, then we'll grant you that approval process and give you that risk score of a low risk score. But if you decide to do a paper airplane, then, you know, obviously, you know, you're not going anywhere in that way, right? So your aircraft does take into account, and we're creating those automated systems for a much more greater risk analysis. And it really, you know, we really look forward towards, you know, local authority deploying much lower cost sensors. And what that means is it really provides that granularity across the environment, where we could definitely see a new type of weather service come around of this future system. You know, one of my favorite movies is like Back to the Future, where they're in the future. And you know, if you haven't seen Back to the Future, I highly recommend it. But you know, the scientist Doc Brown could detect the weather within the second, right? As to where it could go, and it could be in the future we could see that type of granularity and that future aspect using machine learning, artificial intelligence, and with the sensors, a decade from now, that could be really pivotal in future weather. So I'm looking forward to all the innovation in weather, and looking forward to all the innovation of taking that weather data and making sense of it for aircraft to be the most efficient. So when it comes to routing through weather, that's where the key thing is here, right? Do we block off the whole thing, or can we maneuver around the weather itself, right? It may take a little bit of a longer journey, but if we can give that option towards the operator, that just gives them one more advantage to go through that scenario without just holding the aircraft back and delaying the rest of everyone else. So by using artificial intelligence and machine learning with this high active, high speed weather information, we'll be able to really kind of plan those routes accordingly and give the best route possible. Also, our multi-thread data streams really understands those risks, so we give those risks, and then also we provide that emergency service to provide any sort of catastrophic situations to mitigate those issues when it comes to the system. And of course, vertiport design is a very big key issue, right? I know a lot of everyone here, if you search vertiport on Google and you hit images, you'll see all kinds of different vertiports. Obviously, those designs don't take into account weather, right? If you see ones that kind of look like a volcano or like a bowl, imagine the wind shear coming off of that in your vehicle coming, flying, out of the vertiport. That could blow you off a couple hundred feet, right? And so designing the vertiport for the climate, understanding the weather environments, if you have multiple FATOs and multiple eVTOLs landing, what is that wind shear and wake turbulence look like? What does the passenger experience look like? So again, all of these weather dynamics and air dynamics really need to take play when developing these types of systems, right? You don't want to be getting your groceries out in a VTOL and then this other aircraft going because there's a building next door, another infrastructure. It's a whirlwind of stuff, and it's a horrible experience, right? If you've ever been to an airport, you actually have a seemingly experience from going from the plane to the airport. In the future, you won't have that. You will be in the element getting into these things. And so what does that mean when we design these and taking weather into account of it and understanding the surrounding elements? So, at True Weather, we work with them on providing True Weather provides a lot of that insight for us, making sure that as we roll out our vertiport infrastructure projects, that the environment is actually taken in consideration of that design.
And Cliff, I want to add, it's not just an engineering problem. Many times data scientists and engineers will go off in a corner, but they really need to have an atmospheric science meteorologist in that group, because you're not going to really build the perfect situation for every weather situation. So the idea is you want to understand historically what happens in that environment and how then to take that into consideration about how you configure your approaches and your takeoffs and all those things, because you're not going to engineer your whole way out of weather, and you're not going to engineer the aircraft out of it. So you need to, it's a risk game, right? Like, how do we get more value? How do we get more velocity per airframe into an area? And a lot of it has to do with understanding how those winds are going to behave in the future. So you need to bring experts in on that kind of decision making.
Yeah, I completely agree. And some of the vertiports that we hear today that I've heard that are being planned in certain areas have not taken in that consideration, right? And so I could immediately see, a north wind blowing at 20 miles an hour halfway through the day, and they made a corridor for people to walk through, and it's just blowing everything around, and the vehicles are going to be it's chaos, right? And so we're going to spend that money, right? And it costs a lot of money to make these vertiports. If we're going to spend that money, let's do it right? Let's make sure that we don't have to build from the ground up again. So
I think Cliff, what people miss on this is that these types of studies, as well as getting the right sensing infrastructure, is honestly, when you look at the cost of what you're going to do to put vertiports in an urban area, it's budget dust. But yet the value you get back, you can increase your velocity by 20%, right? When weather's a factor, or 30%. It's just an enormous return on investment. And it just boggles my mind that folks don't really understand. It's like the old Fram oil filter commercials in the 1970s. And if you don't know what I'm talking
Yes.
about, look it
Yeah.
up. They say you can pay me now or you can pay me later, right? That's the same exact situation that we're talking about with weather infrastructure and just doing good planning and design.
Right. No, I completely agree. Yeah, we got to think of it now and plan for it now while we put out the infrastructure. 100%. So, want to kind of talk about a little bit about our operations center. Obviously, Skyway has a command center around UAM traffic information for ATM, our ATM solution, our PSU solution, and our data aggregation solutions for UTMs. But we take weather in account for when it comes to this, right? So, we're constantly looking at the data feeds from True Weather. We're making some critical decisions, but True Weather is giving us some really good insights from their artificial intelligence machines to really help drive that human decision if we're closing off a large majority of our of the airspace for our clients and services, right? So it's a bit of a hybrid system where it's artificial intelligence doing most of the handling, but when it comes to those critical decisions, it's a human element to it. And we have a direct feed with the 24-hour operations center at True Weather in our 24-hour operations to do the final critical stuff, right? So, if a big system is coming in, we're cross-referencing that with our partners and making sure that if we're making that critical decision, it is the one decision that we need to make. So again, operation centers are going to be huge to this thing, other than just software being sold to operators, right? So again, we would love to have computers run the world in our lifetime, but we do still think that a human element, at least a little bit of it, is still involved in some of these critical situations when it comes to UAM.
I'll tell you, Cliff, people that I talk to all the time that are former air traffic controllers, 20, 30 years experience in the tower, they tell me that, the human is still going to be a factor, at times. And the way I look at weather is the same way. You can't just use automated products. They'll work 80% of the time and let them run. But when it comes to that 20%, those edge cases where, our models just aren't good enough yet, the human carries a lot of heuristics that can have a conversation with the decision maker about how they feel about the likelihood of something happening, or what are the different ways that the branches and sequels this weather event could go. And having that information really helps to make a better decision. And it's still worth having the human in the loop.
I think so too. And because it's an economic impact for our customers, right? If a computer decided to shut it down and it cost our operators millions of dollars that day, we can't blame Watson for making that decision, right? Or Weibo, or Alexa in this case. So, we need to have that human there going like, no, this is a significant thing. We've looked at the data. We're going to decide this is what it is. And so there's accountability when it comes to making those larger decisions, within those systems. So yeah, humans still play a role, which is another one up for humanity, at least in this century. So,
at least while I'm alive, anyway. That's what I look at it.
Great, yeah. So, kind of want to talk a little bit about our partnership here at Skyway with True Weather and what it means for our customers. It's getting that integrated weather data. All of that really great innovation that Don's doing on his side of the fence is piped in through our system under one cohesive platform. So as you submit your information and your flight plans, and you want to understand what your risks are, weather is part of that integration package. So you're getting that directly into the route requests through your separation services. So it's all under one-stop shop for you to make the decisions as an operator on what you want to do. High fidelity, again, weather advisories are also integrated into it. So we're giving you pre-predictions in geospatial information on top of other information that we have around traffic in that area, right? So, you're getting, a bunch of different variables and the wonderful weather included into it. And obviously here at Skyway, we take the cybersecurity very seriously. So, we make sure that the data it has the integrity and the security along with it. So that way it wasn't tampered with, and you can operate assuredly that, it's a clear sky, not a thunderstorm that you're going into. when it comes to that type of information. So with that, that's pretty much it. I hope everyone enjoyed it. The next webinar that we'll be doing here at Skyway is about UTM intelligence on cross data sharing. We're going to be going over a lot of the security elements of UTM, what kind of industry standards are happening around it, the data integrity, flight data recording standards, and some of the performance metrics that we're seeing here at the industry when it comes to the FAA. Here at Skyway, and at TrueWeather, we're both partners of the Global UTM Association, which is providing global standards for ASTM and ISO across the world. So again, you have one of the leading industries here in providing information and structure for AAM. And with that, we're going to let Brian here, our moderator, kind of go through some of the questions. We'll do a Q&A session. Again, if you haven't submit your questions, please do so now, and we'll go ahead and answer those.
All right. Thank you very much, Cliff and Don, for your contributions to the webinar and the UAM industry as a whole. Thank you, everyone, for watching. And as Cliff already mentioned, request that you follow both Skyway and TrueWeather on social media and the websites that are listed there on the screen. So now we'll transition into the question and answer portion of the presentation. I do want to talk about a couple of things that both of you pointed out, and they kind of stood out to me. Don, for you, there's a false sense of security out there when you're using today's weather data, and I think that's one thing that a lot of people still think that when they turn on the TV and they look at the nearest weather updates, that is gold, right? That they can bank on that. But the future will tell a different story, that right now we're still using those antiquated systems. So I thought that one stood out to me a lot. And Cliff, on your side, the way that Skyway is taking innovations and reducing the chaos and uncertainty in these AAM and UAM mobility operations. So I think that both of you guys are just, once again, sharing my kudos to you about being leaders in the UAM industry. So our first question, I think this one is for Don. Don, doesn't the Weather Channel, what is different about TrueWeather?
Well, government data is the main fuel for most of your weather apps and most of your TV meteorology. There are some proprietary systems and commercial contributions to information, but for the most part, they're not focusing on the things that are around aviation weather, which, as I talked about earlier, you don't get it in your meteorology degree. 90% of the universities that graduate meteorologists do not teach aviation weather. Aviation weather has icing and turbulence and microbursts and downbursts and all kinds of things that they don't teach. And so you really have to know, it's like trying to go to a foot doctor to do heart surgery, right? And so when you watch TV and get your apps, they're not built around aviation weather. So that's the first problem. The second issue is the granularity of the data. Microclimates are not being picked up on the Weather Channel. They're focused on broad weather information, maybe down to the city scale. The same with weather apps that are using general weather data and general weather information. What we do at TrueWeather is we combine data sets that are best for a specific application and a specific parameter, like a ceiling height or a wind speed. And then we're adding these new sensors that they don't have to make that even more reliable. And so, it's like anything else. Like I said, if you want to have the microclimate understood, you have to go to the right practitioners of that. And the general practitioner is not going to serve this industry well. You have to have the specialists, and that's really a low altitude specialist, which is what TrueWeather is.
All right, I appreciate that, Don. Thank you. The next one I think is for both of you. What does the certification process look like for TrueWeather services and Skyway services? Cliff, do you want to start on this one?
Sure, yeah. Right now, we're working with the FAA on what the certification parameters are when it comes to data integrity, especially around archiving information. So if you get an example, there's an incident, right, that happens, unfortunately, right? We can't say that the world's going to be perfect, right, in this sense. But let's say incident does happen. Retaining that weather information during that time is going to be critical as part of the report, right? So, at Skyway being a PSU, as we collect that data, that's part of our certification, that we're building out with the FAA on data retention for future reports and things like that. So obviously it's a work in progress. With the FAA, there's not a lot of requirements and certifications, but we're working through that with with federal government, NASA, and all of our partners here at Skyway.
So,
Right.
So True Weather, my experience, I was 4 years as a senior executive in the National Weather Service. I worked very closely with the FAA on standards around aviation weather, about building new products. There are standards today for a manned aircraft to follow. They have to use approved weather sources. That's written in the rules. And those approved weather sources are either National Weather Service, or they could be third-party providers who have gone through a certification process that says they do the right training, have the right protocols, do quality control on their data. And the thing is the operator themselves has to certify that weather company is doing that in order for them to put that third-party provider on their operating certificate. So that's the way it works today. Now, what I'm doing, working with our partners in the ASTM and with the FAA, who, by the way, the FAA has been very open to this and moving in this direction, is we don't want to put that onus on the operators. We want to put the onus on the weather supplemental data service supplier to meet those standards, those means of compliance, which is why weather should be a third-party service, not just a supplemental service, because you can't fly without weather. And the issue here is putting that certification responsibility on the weather SDSP to follow those standards, which we're developing right now, and we're working with concert with the FAA. And then the FAA is figuring out whether a third-party provider will come in and do the inspections and follow up its certifications on the weather SDSP. This is serious business. Using a weather app may work for visual line of sight, but when you start going beyond visual line of sight, or you start carrying people or heavy cargo, we're going to have to fall back to those means of compliance. So we're working on that. The other thing we're working on, and True Weather will be one of the first weather SDSPs with all those certifications. If they were in place today, the rules, we would be still certified today to do it, just that they haven't yet completed that change. The other thing is that in the past, we've had to certify weather instruments. So those weather observing stations at the airports, they are very expensive. They go anywhere from $120,000 to $250,000 a piece. And we knew early that if we wanted to close these weather gaps, we've got to come up with a better system. So we're moving from, and really we're just practicing what the UTMs are doing, what the FAA and NASA's already been pushing on, which is moving to data performance standards, and then making risk-based decisions based on the data you're getting, the weather data you're getting. So, and having that data, have the metadata with it to tell you what the accuracy of that data is. So when you make those risk-based decisions, you know how much a buffer you have to put in your decisions, right? I mean, if you're flying a pizza over Kansas, do you need to have the same fidelity of weather information as you would say over a city where you're flying people over Manhattan? And the answer is going to be no. So we're building a flexible system which will allow for the IoT sensors to fill these gaps. We'll validate and calibrate how those data are performing. We will put metadata on that and then make that available. So whether SDSPs can say we're certified, and giving that off to the PSU so you guys know you're covered from that perspective. And the third thing we're looking at is simplifying, what True Weather does is we take all this weather data that's in a lot of different standards that you would throw up if you had to integrate that into your system. Your software engineering costs would go through the roof. What we've done is we translate that into JSON and GeoJSON, and that's the language everyone's using now in UTM. And so we're going to try to enforce that as a standard also to make sure whether supplemental data service providers are translating that data into simple insights. So that's what we're working on the regulation and standard side.
All right. Thank you very much. Okay, next question. How long do you think it will take for each of your companies to provide services nationwide?
We're doing it now. We're doing it now here in the U.S. with a lot of very high level products. We can do it. We're doing it in Canada, and we're also moving now into Europe, Singapore, Australia, and if the business model's there for us, we will get what we need to run what we do in these locations. And also we have the ability to plug and play sensors. So right now we have several clients who are buying different types of low-cost weather sensors that they deploy, and we just integrate that. They plug it in, they put it on, and it's in our system. We feed it back to them through their API. There's no cost to integration for them. It's simple, and it closes these gaps. So we provide that service today.
All right. Yeah. Thank you, Cliff.
And we're helping a lot of that too. We're actually planning with our vertiport developments, making sure that these weather sensors are integrated into the port itself. So that adds to the cluster, data cluster, at True Weather, provide better accuracy and aggregate that information. But at Skyway, obviously we're a lot more operational intensive when it comes to data and terrain and traffic services. But right now we're providing services in Florida, and it will be a 3-stage process over the next few years, providing full airspace services across the U.S. So we do see, sometime 2024-ish, where we're fully operating here in the U.S. Across the nation, and as well as parts of Canada as part of that deployment. That's pretty much it.
All right. Thank you both. Next question: isn't the international community already building and designing vertiports, Cliff? And if so, can you provide the difference in what you see as vertiports in the United States?
Yeah. So, I want to say there really hasn't been an actual vertiport yet, right? In a way, or globally, there's a bunch of great sketches and a bunch of pipelines, if you will, across the U.S. I do know. Well, I want to say there is one in Singapore, I do believe, and a few others, but they're very smaller, and slower operations than what you would see a vertiport being high volume operation, right? So when it comes to developing these things, I do see local authority, especially city planners, taking the planning part of a vertiport very seriously when it comes to the zoning aspect of it. How does that affect the surrounding neighborhood and things like that? I do see a lot of these vertiports, taking place at airports, which, again, it's a bit different, because if you have, the view of all the weather systems that are at the vertiport, at the airport, the moment you leave that airport, you're pretty much blind, right? When you get to the next vertiport that may not have that fidelity and that investment infrastructure that the airport had given you. So, there's a lot of things to take into account here, but looking at industry, hearing industry, and working with industry very closely, I will say we're going to see some vertiports popping up, if not later this year and all through next year, very rapidly, as the eVTOLs start to get certified and airworthiness to fly, and those productions start to ramp up. So it's going to be an exponential growth, I believe, here coming up very soon, which is really great. Of all the companies that are in this space, doing multiple technologies and working, day in and day out, providing and creating this infrastructure, it's just a really great time to be in it.
Yeah, I agree. It looks like that will conclude our question and answer portion of the presentation. Just to say thank you to everyone that's watching today. If we didn't get to your question, or if you think of a question you'd like to ask on either of these topics, please feel free to email me at brian@goskyway.com, or either Don or Cliff directly. I want to hand it back off to Cliff and Don just to see if you had any closing comments before we go ahead and end the presentation today.
Well, first of all, I think, again, having these discussions are just so enlightening to folks. Our goal is right now is to build and educate, right? my experience in supporting over 500,000 flights in my career, in organizations that I ran and built myself, I have pretty good insight on just about any mode of transportation, helicopters, drones, and what those challenges are. And what I'm really trying to do is say, let's anticipate what's going to happen and get out in front of this. It's so easy just to take an approach where we do evolutionary and just do a little better than what we've been doing, especially in the aviation weather business. But there's so much science and technology that's in the labs and universities. I often feel we're underperforming as an industry because we can't get it out into commercialization and operations. We could be doing a lot better than we're doing. And there's a lot of structural reasons for that. And I'm not pointing fingers or anything. But what I saw when I saw this industry stand up was that this was the best business case for micro weather in the history of industries, right? We've always had a need for agriculture and for construction to have micro weather, but you weren't able to pull that together and build the infrastructure and make the business case for it. There wasn't a coalition. This is going to be the best business case for micro weather. And if we miss this opportunity to take advantage of the technology we have today and these new systems within this industry, I wrote the Next Gen Weather Comps and part of that in 2005. And the biggest challenge we had was the legacy systems the airlines had just could not move fast enough to adapt new technologies. And today we're still waiting to get better weather services out there 15 years later because of that legacy software. This is a clean slate. Anyone who's fighting it is just not understanding. We could do a lot with this, and we just need to be innovative, take this bull by the horn, take advantage of the lessons that we've all learned, and let's make this happen and really increase the profitability of this industry.
All right. Thanks, Don. And Cliff?
And to got off that, it's amazing how fast the FAA responds to everyone here at the industry, right? They're moving, they're trying to move mountains as fast as they can because industry is just moving a lot quicker than they can anticipate. But they've recently put in so much effort into employing new people, putting new structure in, and really kind of driving this industry. It's going to be unstoppable, and that excites me the most. Right, is that this is happening? Like they're enabling it. NASA's fully supportive of it, and everybody in this industry is very friendly and innovative. Right, at Skyway, our team really sees the future where there's thousands of drones in the sky and there's hundreds of VTOLs taking people around. It's that Jetsons times 100 type future, that we're building here, and we're going to see it in our lifetime. And so, for me, that's really exciting, to be able to not only get a pizza and a coffee via drone, but also, not having to be on the freeway and traffic to get across town. Right. I think that's going to be super cool. And, I'm excited for that.
And I want to say the FAA and NASA have been very aggressive at leading in this. I mean, if you look at the NASA way they've approached this, it's been very refreshing to me because they're really incentivizing the small businesses to go out there and help drive the innovation. And the FAA themselves, working with us and working with the ASTM, very open to, we had to generate this groundswell though, and we support them, they support us. We could do this together if we all get on board the train.
Yep. Agree.
All right. Well, I appreciate it, everyone. Thank you again for watching, and wish everyone a good rest of your day. Thank you again to Don and Cliff for your input in the webinar, and hope everyone enjoys their week.
Thank you for having me.